Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode question number 6 by 3 to sum 4. Input is a BST. Okay, given the root of a binary search tree and an integer k, return true if there exist two elements in BST such that their sum is equal to k, or false or vice. Okay, so what they are asking us to do, they want us to find two elements in the BST. Okay, two nodes in the element, distinct nodes, and this value is equal to what? Those sum is equal to the integer k. Okay, let us understand this. See here, take this as our example. So this is the binary search tree they have given. Okay, fine. Now they are asking us to find a target as 9. Okay, I can say this 5 and this 4 can be one target, right? Because 5 plus 4 is what? 9, right? Okay, this 3 and this 6 sum up to give what? And 9. And this 2 and this 7 sum up to give what? A target 9, right? So I will return what? A true. If there exists any one itself, I will return true. We have 3 possibilities that we should return false. I will return what? True. That's it. Now, if target is 15, okay, if target is 15, whether two node value gives me a value 15, okay, let us check whether anything to know whether the 6 and 7 is the maximum among those, right? So the 6 and 7 itself sum up to give what? A 13 only. So I can say this 15 cannot be found. So it will be what? A false. Can you understand this? So you want to return either true or false for this binary search tree. Okay. How can we do this? Okay, let us understand this. So the first approach is that the easy approach. What we are going to do? A set approach. Remember it, right? Set approach. By how? Okay, just to traverse the binary search tree entirely. Just traverse the binary search tree entirely. Okay, so traverse first. Okay, then secondly, what should I do? I should check whether the target minus the current root's value is equal to in set. Then I will return what? A true. Okay, I will try run it. Initially I will take a set data step. Okay, now initially I am at this 5. Okay, whether this 9 minus 5. So 9 minus 5 is what? A 4, right? A 4. Why we are doing target minus root value? Because see here, root value plus some any other value x is equal to what? A target, right? Okay, to get this x, what should I do? X is equal to target minus a root dot value, right? So that's why we are using this one target minus root dot value, right? Okay, I'm choosing this 5 into my set. Because 4 is not inside my set, right? Okay, I will post this 5 inside my set. Okay, now I'm doing what? Simple pre-R transfer. Let us take simple pre-R transfer. Now I go here. Now 3. Now 9 minus 3 is what? Is 6. Whether 6%? No. So go down. After putting this 3. Now, whether this 2 is, 2. 9 minus 2 is what? 7. Whether 7 is in my set? No. Let's include 2. Okay. Now it is what? And null. So backtrack. Again go here. Null. Again backtrack. Again go to this 4. Now 9 minus 4 is what? 9 minus 4 is 5. Whether 5 is in my set? Yes, I got a 5 in my set, right? I got 5 in my set. So what should I return? I should return a true, right? So this will return what? A true. So return what? True. So if it return true, then what is this should return? It should return a false. Can you understand this? These things should be written a false. Can you understand this? Yes. Now, what should this 3 return? This 3 returns, hey, my left subtree is false, but my right subtree is true. So it returns what? A true. So that I want to return what? False or true. Or operation will leads to what? If either one is true, then it is true, like that. Okay, so I want to check whether it is false and it is true, which means what? I'm doing an OR operation to my left subtree and also right subtree value, return value. And I'm returning what? A true here. Okay, now I will go to this right subtree and check whether this 9 minus 6 is what? 3. Well, 3 is present. Yes, 3 is present. So it also return what? A true here. Can you understand this? So true. So absolutely this will return what? True. So I will get the answer as what? A true. Can you understand this? So this is set approach. So what is the time complexity approach? I can say my time complexity will be say I'm just traversing each and every node, right? So at the worst of the time complexity, we don't have this target as our sum. Then what will be? It will be number of nodes and there's set operation. We are just checking in the set, right? So it also takes at the most log n times. So at the worst case. Okay. Now, what is the space complexity? I can say at the most it can store O of n. The set stores at the most n elements, right? So this is a time and space complexity analysis. Now, whether we can still optimize it. See here, it is what? N log n, and also what? It is n, right? For the space complexity, it is what? n. Okay, whether we can optimize it or whether we can have any other approach. Okay, U1 is what? U1 is a binary search tree. Okay, what is the property of this binary search tree? See here, if it is a binary tree, it is a way we want to do, but it is what? A binary search tree. So it is like something like a sorted array. If you want an array representation, this is what? A sorted array. They were given a sorted array. So instantly, whenever we see a sorted array, our mind looks like, okay, whether we can use a binary search, right? Like that only, in binary search tree also, we want to use something like a traversing that binary search tree. Okay, let us understand. First of all, my left subtree always have my value as which is less than the node. Less than the node will be my left subtree values, entire values. Okay, my right subtree values will be what? Will be greater than the node, right? Greater than the initial node, right? This is the property of binary search tree. Okay, let us understand this. First of all, I'm taking this example. Now, initially I am standing at what? Standing here. Okay, so it is what? A 5, right? Okay, it is 5. And then what is my target? I can say my target is 9. Okay, I'm just traversing this entire tree. But again, I will traverse in the particular route to find whether it is R or R. Okay, like let me teach you. See here. First of all, I am standing at this 5, right? Okay. Now I will take this 5 again. And what the target I want to find now? 9 minus 5 is equal to 4. So 4 is the target I want to find, right? So I want to check whether this 5 is equal to 4. No. Then 5 is what? Greater than 4. So I can say going to this right subtree is waste, right? Can be ignored, right? So I will go what? To the right subtree. Okay, I'm going to right subtree. Now it is what? At 3. Okay. Now 3 is greater than or equal to or less than 4. It is less than 4, right? So I can say going to this left subtree is waste. So I will go to what? A right subtree. So now whether this 4 is equal to or greater than or less than 4, it is equal to 4. So I can say it is true, right? So I'll written what? A true here. So true, and here also it returns true. So from this only I found here, right? So it will return what? A true here. So my answer is what? A true. And understand this. So we are picking one element, one node, and we are just finding any values. Any values will be in that binary search tree. It is like what? First step is traversing the entire tree. Then second step is what? If target minus my current root value is in my binary search tree. To do that, we can use a search operation in my binary search tree. Like ignoring the left or right subtree, like that. Okay, it is like a binary search, doing a binary search. Still you want a representation, just do a binary search. It is like a binary search. Okay, now there is one important thing like edge case. Okay, let us understand what is what edge case means. See here, let us consider there is 1, right? 1. Then here have something like 5, and here now something like 7. Okay, this may more binary search tree. Now, if I ask you the target is 10, then whether we can form 10? No, right? Because 5 plus 1 is one possibility. 5 plus 7 is another possibility. Then 1 plus anything? No. That's it. So that's the maximum possibility. Maximum possibility are 1 plus 5 and 5 plus 7. So these are the two maximum possibility, and it will give for 6 here. It is 12. So at most I can get either 6 or 12. Apart from that, I don't get, right? So, but in our previous approach, I will take this one first, and I will check whether we can get a target, right? What is the target? Is 10 minus 1 is equal to 9. So I will check this. No. So what is the 9? 9 is greater, right? So I will ignore this left subtree and I will go to this 7. So 7 is also what? Less than 9. So I will also go to the right subtree. So it is what? That's false. It also returns false. Fine. Now, when I am going to this 5, I will check here, right? When I am checking here, it is 1. So 1 is what? 1 is less than 5. So I go to what? Go to the left subtree. Now I find this 5. So I written what? A true here. So it also written what? True here. But we want a false statement here, right? We cannot take one root node as twice. So whenever we are searching the element, we want to find what? Whether it is the same node or different node. So we want to take what? A distinct node. A distinct node. So this is the edge case we want to focus on. I will solve it in word code. Okay. Now what is space complexity and density? I can say my time complexity will be O of n, and to search in my minus is 3. Okay. In best case, what is it? What is it? It is a height. And in worst case, it will be what? N square. I understand this? Okay. So in best case, it will be O of h, and in worst case, it will be n square. And what is the space complexity? It is O of h, because we are using what? A recursion approach, right? Here we are using what? A recursion approach. So recursion also takes some space. And it will be what? O of h. So it is my time and space complexity analysis. Fine. Now we have another analysis, another approach. What is that approach? We may ask. So it is a third approach. So what is the third approach? Okay, let me take this as our example. Now observe this carefully. We have some property like, if I do in-order traversal, we do in-order traversal in my BST, then what is my answer? It is like a sorted list, right? A sorted array. We will be getting what? A sorted array. Can you understand this? So by using the sorted array, we can do by using what? A two-pointer technique. Okay. I will teach you how to do this. Okay. Initially I am here, right? Okay. In order, what we will do? We will go to the deepest left. Then while returning, we will get the root. Then we will get the right. So it is like what? A left, then root, then right. Okay. Initially I am here. Now I will go to the left side. Okay. Still we have left. Okay. Go here. Okay. Again go here. It is what? A null. While null, I don't take it, right? I don't take it. I backtrack. While backtracking this 2, right? So I will take 2. So I will take 2 here. Fine. Now, again, I will go to this left, right side. It is also null. So I will backtrack. Now, both left and right are completed. Now I backtrack. By backtracking, I will insert this 3, right? Okay, insert this 3. Comma. Now I will go to the right side. Okay. Now I will go to the left side. It is null. Okay, backtrack. And I will take this 4 again, right? Okay, 4. Now I will go to the right side. It is null. Okay, backtrack. Again, backtrack. Again, backtrack. Now I will take this 5 as our answer. Okay. Now I will go to this 6, right? Okay. Now again I will go to this null. Okay, backtrack. Again this is 6, right? Okay, 6. I will go to the right side, and I again go to the left side. Again backtrack. Again go to the left side, null. Again backtrack. Sorry. When we are backtracking from the left side, we want it said what? 7, right? Now I will go to the left right side, and then it is null. So I will backtrack. Again backtrack. Again backtrack. Again backtrack. So at most, what is my answer? 2, 3, 4, 5, 6, 7. So it is what? Is what? A sorted array. Is what? A sorted array. So from this sorted array, I can say we can do a two-pointer approach. How we can do this? We may ask. Okay, let me demonstrate it. Okay, let us take our target is what? 9. Okay, so target is equal to 9. So initially I place a pointer here, and initially I place a pointer here. Now it is what? 2 and 7, right? Okay, let me take another example after clearing this. Okay. Now, it is 2 and 7. So, it is what? 2 plus 7 is equal to 9. So, I will written what? True here. Okay, let me take any other example like 1, 2, 5, 6, 7. And my target is something like 10. Okay, let us take 9. Let us now take it is as 9. Or let us take it is as 7. 7. So, 7 is similar. Okay, no. Observe this. 1 pointer is here. 1 pointer is here. Now, what is the sum? I can say my sum is something like 7 plus 1 is equal to 8. So 8 is what? 8 is greater than this 7. Greater than 7. So which pointer should I move such that my sum will be reduced? Should I move this pointer here or this pointer here? I want to move my right pointer here, right? Such that my sum will be reduced something. So that I can say that I maybe have some possibility, right? Possibility to have some value. So I will reduce it. Now see here, 1 plus 6 is what? 7. So I got a target sum, right? So I will return what? True. Okay. If sometime it will be like 2, 3, 5, 6, 7. But the target is what? Target is something, it will be like, sometime the target is something like maybe a 12, like this. Okay. In this scenario, I want to first check whether, these are the 2 points, right? Whether it is smaller or larger. So it is what? A smaller. 8 is smaller than 12. So I want to move this pointer here. Okay. Now again, 9 is also smaller than 12. Okay, again move this pointer here. Now it is what? It is 5. It is 5. So now this and this sum gives what? At 12. So these two are equal, and I will tell you the result as what? A true. Can you understand this? So this is the thing we are going to do in this approach. So first thing was what? Take an in-ordered traversal and put into an array. Okay. Now what is the second step? Just keep track on the two-pointer approach. Just use a two-pointer approach in that sorted array. We will get a sorted array, right? So these are the two steps we want to do in this approach. Okay. Finally, coming to the conclusion, what is the time constant for this approach? I can say my time constant will be what? My time constant will be what? O of n. Because I am traversing each node only one time, and also I am just doing this two-pointer approach, and this two-pointer approach is also what? N times, right? Only runs for n times. So it is n plus n, it is 2n, and also constant will be removed, so it is n. Okay, out of space, it is also O of n. Because I am using what? Auxiliary array. So it is way better optimized than the above two approaches, right? So this is my optimal approach. So let us see the code. First we can see the optimal approach. See here, auxiliary space is equal to empty list. Now I am doing the simple in-order traversal, right? First left, then taking the root value, then I am taking what? The right side, right simply, a recursion part, okay? Then I'm just doing what? A DFS of root. I'm just calling that function. Now, f comma r is equal to 0, len of auxiliary minus 1. So I am keeping 2 pointers. Now, why these 2 pointers are in my limit, which means what? F is less than r. Then I can do some process. What is the process? Just take the sum of those two values, and if that sum is greater than my target, then what should I do? I should reduce my r pointer. This is what? I want to reduce the sum, right? That's why I is reducing the r pointer. And if it is less than k, then I want to increment my sum, right? So I will increment my f pointer one time, and else I will return what? True. Else means what? It is equal to condition. Then I want to return true. Let me submit it. Yes, it is submitted successfully. Now in Python, if I don't return anything, it will return what? And none. None is what? A false. But if you are using a C++ or Java, you have to manually return a false. Can you understand this? Okay, fine. Now we are just seeing saw the optimal approach. Now it's time to see other approaches. Okay, let me first explain you the search approach in the binary search tree. Okay, first of all, see here, I'm just traversing the entire tree, and I want to just check whether the current root, okay, that current root is subtracted from the target. Okay, that current root value is subtracted from the target, and I'm just passing what? That root value also. It means what? If the correct value is 5, I will minus the target. Target is suppose 9, I will minus it. So 9 minus 5 is what? 4. So I want to search whether 4 is present or not, and also I will return what? I want to call by what? I want to send the argument as what? The root. I want to send the root. Why? Because if that again exists, then only I want to return true. If the same node, I want to return false. Like I told you in the example, right? If 5, then again I don't want to take that 5. I want to take another node with 5 value, right? That's why I'm just again traversing here. See here, if not root, then what should I do? I just return it. Return false. Now, if root dot value is equal to target, and root is not equal to node, which means what? Which means that current value is equal to root, and also that current node is not equal to the initial value we have sent. Then I will return what? A true here. Okay, now if the root's value is less than target, then I want to go for what? Go for the right subtree. And if it is greater than the target, then I should go for what? A left subtree. That's it. And return it. Yes. So finally we will run what? Either we have anything in our left subtree, or either we have anything in our right subtree. We will return what? A true. Simple. Yes. Now I will return what? DFS of root. Let me submit it. Yes, it is submitted successfully. Now, at last, we are going to inside what? A set approach. Okay, I'm taking S is equal to set of. Now, DFS of root, and I'm just returning false if the root value is what? A null. Now, if k minus root value is in my set, then I want to return what? A true. And then s dot add of root dot value. Then I want to return DFS of left subtree. I'm taking the left subtree, or the return value of right subtree. If any one is true, then I will return what? A true, and return DFS of root. Now at last we are returning what? DFS of root. That's it. So let me submit it. Yes, it is submitted successfully. Thank you.
I don't know about that.
So the net, it was gonna be like